Hello everyone, and in this project I'm going to show you how you can use the timer TMR0 as a counter. So this is the project over here. I'm gonna click a button on RA4 5 times, and these LEDs on the port D are going to glow for 5 seconds, and then I can do this as many times as I want. So let's go 1, 2, 3, 4, 5, and here you go. Here you have 5 LEDs. Then they're gonna glow for 5 seconds, and we can do it again. 1, 2, 3, 4, 5, etc. And and for this we will see how a timer of a microcontroller is used. This is very important to learn. So let's get started. Okay, so here is the schematic of the program. So here I have a crystal oscillator that is not important. I already said you don't even have to use it. In Proteus, in real life, of course, you have to. Here is the button. When I click 5 times, it is gonna start to flash these LEDs. So yeah, when I bring 5 logical ones on this particular pin, all LEDs on port D are gonna glow for 5 seconds. So yeah, it needs to be RA4 here /T0CKI, because that is the pin for the timer 0 module. So let's go to the book first and see what is timer Z. Okay, that is a module that is used in a PIC microcontroller. It has a watchdog and a timer, watchdog timer and timer in particular. So in heavy details you can read about it. I'm just gonna cut to the chase. So here you have a block diagram or the schematic of this timer. Okay, now there are 2 ways you can bring impulses to it, with an external oscillator or through pin RA4 T0CK, signal external source. In this particular project I brought the impulses on the RA4 pin. I didn't use the crystal oscillator. When you use the crystal oscillator, it divides the external oscillator with 4. But if you want to use a watchdog timer, a watchdog timer is an internal timer, as you can see over here, and it has an internal oscillator of 31 kilohertz. Okay, so here is the block diagram. You can see there are some logic gates, there are some prescalers. I'm gonna cut to the chase. Okay, now in order to configure some particular things in this particular timer, you have to go to the option Reg Register, option double line Reg Register, and there we have 7 bits. So and this is pin RBPU, in INTDG, and so on. And let's see what in particular does what does it stand for. So RBPU is port B pull up enable bit. This isn't important for us, and one thing I have to say is this isn't correct. I sent the message a message to Microelectronica and said this was a mistake that is made by writing. It isn't a huge mistake, but yeah, here from PSA and above to here RBPU, everything has to be changed. From this here is 0 1 1 0 1 0 and to PSA. I saw that on data sheet of the this particular PIC microcontroller. So yeah, it isn't important. We can also look at this special function register in the data sheet of this particular microcontroller. So this here, if you bring 0 or 1, it isn't important for us in this particular program. We don't even use port B, so nothing to see here. So INTEDG. So that, let's see, it stands for interrupt edge select pin. So if you want an interrupt on the rising edge of int pin or falling edge, you can configure it. But in this particular example, we are not using an interrupt. Okay, that we'll do that I think in the next video. Okay, so this is more T0CS, timer 0 clock source select bit. So here you can have a transition on T0CKI pin, or you can use an internal instruction cycle block with an external oscillator frequency divided by 4. So here you can select the, what would be the clock source bit. Do you want here to have the clock source bit from an external oscillator, or you want to have a clock source bit on the pin RA4? So this is very important, not just because of this particular example. You can listen to me, you can even measure a frequency of an external oscillator. So this is very important to learn. So you can either use the clock oscillator, or you can bring some frequency to the RA4 pin. It is your choice. But in this particular example, we used an RA4 here as a clock source bit. You will see why. Okay, oh sorry. So here we put 1 on this particular bit. Everything else is 0. We'll see why. T0SE. This is the 4th bit in this register, and it is a source edge select bit. So this is gonna increment register from low to high or high to low. It depends what you want to use. So here we put 0. So we incremented it from the 0 to the high voltage state, if you remember. But also, if you want, you can increment from high to low. You just have to make this a pull-up resistor, not pull-down. Okay, now we have a Prescaler assignment bit. So we can, if we use one of these, but it is not important to use this. Now it's not important because we are using. We just increment the impulse, but you can use all. If you put 1 on this particular bit, you are using a watchdog timer. If you are using 0, you are using the timer 0 module. Okay, so here you have a watchdog timer, and everything else over here is a timer 0 module. Let's see one more thing here. Here we have a watchdog timer, and everything else is a timer 0 module. And here we have a register. So this is an 8-bit register long. So we can store values from 0 to 255. And we can, in this here particular example, now here you can have an interrupt. So something interrupts the program when a specific value comes to this 8-bit register, but we'll do that in a next example. Now we're just gonna do on these flashing LEDs, and here we have the prescale rate select bits. We don't have to use it, but in this particular example, which is similar to my program, you will see they configured that we need a prescale rate that is equal to 1 divided by 1. So this prescale actually just divides the frequency or of the watchdog rate or the TMR0 rate. and here are the values. So you cannot have prescale rate 1 divided by 1 if you use this timer 0, but yeah, so these are the combinations. What I want to say is that not all microcontrollers have watchdog timer rate. So it's I think in older ones you have. I don't think you have in newer ones watchdog timer rate, but I'm not really sure about it. So here I think I sent a message to Microelectronica and said I think this was a mistake and it should be rewritten. Okay, now that is it. Now I think I said what I needed to say. Let's go to the program. And sorry, the font is a little bit I need to change the font. So here I go to editor settings, open options, and yeah, I'll make a little bit bigger so you will see the code. Apply. Okay, so here we have the code. Now I have void main that is started of the program. I configure the pins as digital, nothing unusual, but let's go. So here I put that the pin on RA4 is gonna be an input. So when I want an input, I put 1 on that particular input. I put TRISD as an output, so all the pins on register D are or on the output, and the initial value port D is gonna be equal to 0. Now only thing that I needed to do is this option reg.f5 is equal to 1. So this refers to T0CS. So this is a transition on T0CKI pin. So this is on this particular pin, RA4. It doesn't refer to the external oscillator. Now, here let's see the code. Now I put the 0 on this register here, timer 0, which I told about you. Here you have timer 0, and this here is either a counter or a timer. In this particular example, it is a counter. And then here I have a next situation. I have a while loop, endless loop, and it says if timer 0, if this timer 0 is gonna be equal to 5, then the output on the port D is gonna be equal to all ones, and then I have a delay of 5 seconds. Then port D goes to 0, and I give timer 0 a value of 0. But because I used option register F5, let's see that register over here. The transition occurs on this particular pin, and if you don't change anything, everything else is 0. If you don't put a 1 anywhere else, it is like a 0. So let me see. So this here, T0SE, it says timer 0 source edge select bit. So if I put a 0, it will increment on low to high transition on TOCK1. So when I bring a logical high over here, then this timer 0 in the program TMR0 is gonna be 1. And if I bring it 4 more times, then the program asks, is it 5? If it is, then do this, and then I will give it a 0. And that's basically it. So let me just start a program again. Okay, so 1, 2, 3, 4, 5. All LEDs glow for 3 seconds. Let me just bring it a little bit closer when these LEDs don't flash. Okay, so when I click here, look at this rectangle over here. It means it is gonna be if it's red, it means it's gonna be logical high. So here you go, 1, 2, 3, 4, 5, and it flashes over here.
So yeah, so this is how you use Timer 0, the module of a PIC microcontroller, as a counter, and it is a very useful tool that you will use in the future when you become more experienced electrical engineer. So I hope you learned something, and yeah, see you in my next video. Have a nice day.